Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. Today we going to start your chapter number 16 from your textbook page number here 203. So 203 is your textbook page. The chapter number 16, that is about the rate of reaction. As you know that we already done this chapter in detail. So due to revision of the quiz, so let's start to revise this thoroughly. As you know that the word here that is mentioned as what is a rate of reaction. First, you should know that the term rate. Okay. So here you can see that couple of reactions like this one here. What's happening here in this diagram, and the copper on this roof takes years to react in the air. So these are different types of reaction that happen. So let's see the proper definition of this all types of reactions here. The next screen that just I shared with you. So you can find out what does rate of reaction mean. If a question will be like this, so what you will reply and what should be your correct answer. The speed of reaction is called rate. Okay. So as I ask you what is rate, so what we call speed. You know that speed have two units. Okay. How mean to say units? It move with respect to time and also cover the distance. In the same way, how much time is taken to complete a reaction. Understand? Depending upon speed, there are three types of reaction. Now, when we depend on speed, so we have three types of reaction. The first one, as it's mentioned here, that is very slow reaction. Second is reaction with moderate rate. And the third one is very fast reaction. Slow one, it's written here, mentioned, you can see that. The fast reaction or moderate, and this the very fast, within friction of second this happened. Okay, so hope here you have all your concepts clear till here. If any question, you can raise your hand, otherwise I move to the next slide. Is it okay? Okay, just show me the thumb. Okay, or even you can type in the chat. Okay, or understand like this. Okay, nice. Now here the reaction rates, it's depend upon what. Thank you, Mr. Naveed. You can see the very fast reaction as the examples are mentioned here, moderate and the very slow reaction. So very fast, in which magnesium and hydrochloric acid react, sodium and water burns a match, combustion of fuel like this. And moderate one, food spoiling, you know that, rusting of iron, baking a cake, food digestion, cooking, etc. This is the example of moderate one. And the very slow one, like forming diamond, weathering of rock, setting concrete, silver crunching, etc. These are examples. So you should know also about the type and you know about its example. Now let's see the formula that we use to find the rate of a reaction. So what is it? Now, change in concentration. Concentration mean amount actually, okay, of reactants into products in a unit time. Okay, so the rate of reaction, what? That is the amount, okay, of reactants or products in unit time is called rate of reaction. You can take anything. Okay, so rate of reaction is equal to change in concentration divided by time. So concentration is denoted by or represented by delta C. This delta mean change. This sign delta, it's mean change, and C represent here concentration. And you know very well this, the small t is representing here time. So the units of rate of reaction is mentioned here. For concentration, mole dm per cube, and for time you write here seconds. Very simple. Any question, you can raise your hand, otherwise type no in the chat, then I move next. Okay, only Nabil understand. What about the others? Mashallah, we have. Okay, well done, Waleed. Thank you, Ahmad. Mashallah, now we are more than 13. Okay, move next. Okay, Mr. Sadiq, thank you. Now, the first thing in the rate of reaction that affect and how reaction going on and how reaction proceeds, let's see this thing. We have here almost three things. We will learn and understand one by one in a brief way. So let's see. Reactions, particles and collisions. How reactions going on? A reaction that happens, this takes, or in a reaction, the reactants in which the particles are present of, you can say that the molecules or the atoms, they collide with themselves, with the wall of the container, and in this way they collide. So this collision we name as collision theory. Before we can get a chemical reaction, particles must collide, crush with each other. The particle must collide with enough energy to cause a reaction. That is very important point here. If particles are not collide or hit with one another, there will be no reaction. And you know very well, when they collide, the collision should be effective. The collision should be effective. So what we call effective collision, that can proceed towards a reaction. Otherwise, the reactant may be at their place. You can say that hundreds of years or millions of years, if there is no collision, no reaction will happen. So to get or to take an effective collision, we should know that there should be activation energy. Okay. So what is activation energy? The minimum amount of energy needed for the particles to react, or you can say that to collide with one another. This is called activation energy. Okay. If particles collide with less energy, mean to say they don't have that same amount of energy that will move towards the reactant to the product, there will be no reaction. So it's mentioned here, then the activation energy, they will not react. The particle will just bounce off each other. So there is no, you can say that new things or products will not form. They will just go back to in their original or their previous condition. Okay. Now, after understanding this, let's move to the next slide here. Method used to measure the rate of reaction. Also, you can see here in your textbook, when you open your page number 204, now we are on it, to measuring the rate of reaction, how we can measure the rate of reaction. Okay, so after that, let's see the slide here. Collision, mean to say strike with one another. Okay, so there are two ways to measure, find the rate of reaction. One is the measure the rate at which reactant is used up. First thing what we can see or what we can use or measure the amount of reactants. Now, what is reactant and product? For this, I'm just going to draw here a simple equation. You can see that, for example, A plus B, that is the left hand side of your chemical equation, and this convert after effective collision or reacting, they form C plus D. So the left hand side is called reactants and on your right hand side is the product. Okay, if you can measure how much the amount is formed or what is the rate of reaction, you need to find two things. First is you can find the amount of reactant that used. Okay, you know very well, I already gave you many examples, like if you want to know how much you can make a sandwiches, you can easily count the amount of patties or toast or the burger that you used. Okay, so this is the first, in the first situation you can measure the amount of reactant that used up. Obviously the things that you use that convert in product. The second thing is you can measure the rate at which the product is formed. Okay, or in the second condition you can measure the amount of product that is formed, and you can easily find out the rate of reaction. So instrument used to measure volume of gas, that is first is your gas syringe and second is gas jar. Okay, so you can see here even in your textbook, I just show you the page. Here we are. Now this the gas jar. Okay, the reaction is going on in this conical flask. When the marble and the hydrochloric acid react with one another, a gas is produced, and this gas moves with the help of this, and it's going to store here. And here you can see that the graduations are there, and from here how much it will lower the level of water. It means the bubbles are coming here, and you can easily measure the amount of product here. Okay, because reactants are here. And in the second condition you can measure with the help of the syringe. Okay, what amount of gas is going to gather in this syringe, this will move back, and here easily you can measure the amount of gas. Okay, so my dear students, still here, if you have any question please raise your hand, otherwise type no in the chat. Okay, thank you Umar, Sadiq. Okay, what about the others? Thank you Muhammad Mustafa. Everyone please participate and reply quickly. Okay Muhammad. Now let's move to the next slide, that is about a chemical reaction that just I showed you from your textbook. Now we are on the slide here. What can be measured to calculate the rate of reaction between magnesium and hydrochloric acid? Okay, so as you can see here, that is Mg, this for magnesium, and hydrochloric acid HCl, because I write here to balance the equation. Okay, so when it moves next we get MgCl plus hydrogen. The amount of hydrochloric acid used, we can measure this, how much it's used up. Second thing, the amount of magnesium chloride produced, it means the product, how much it is formed. And the third thing is the amount of hydrogen produced. Again, the same product we can also measure. So we have almost three things here to just going to help us to find the rate of reaction. So if we can measure any of them, so we can easily get the amount that used or formed even. Okay, now next slide here, you can see that what's going on in it. What equipment is needed to investigate the rate of hydrogen production? Okay, this especially for a gas, and very simple answer that is mentioned here, a gas syringe. You can see here when the reaction proceeds, what happened, hydrogen start to move from this glass tube to the gas syringe. As it's pushed back, the syringe moves backward, this plug, and then you can easily calculate the amount of gas in it. Now, a very important part of the lesson, that is about the graph to explain the rate of reaction. You know very well about it, yeah? So let's again discuss this graph. Graph explains the rate of reaction. How, my dear? Look, you know two things. First, that is the 0 point. It's mean here both things are zero. What the both thing? One is the time, okay, and second is your amount of product. Okay, you are taking here the amount. For example, you are taking here as gas. Like here, 5 seconds. For example, 10 seconds. Here you have 15 seconds. Here 20, 25, 30, and like so on. Here you have 5 dm cube, 10 meter, 15, and 20. For example, like as time, just you add and let the reactants to react. Time start to move. Okay, tick, 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 tick. It's come at 5. Here you can see that at 5, the time is going in this way. At that level, the amount of product is also start to form almost here. Okay, now when you reach at 10, you can say that it's going to touch this point of the graph line. As time is moving almost 15, the amount is also going to increase, but not in the same case that happened here, because 5 seconds, it's almost equal to 5, but after more 5, it will little bit reduce, because it should be at 10 if it's going or moving in the same way. It's mean with the passage of time, mostly the amount of product is slower down. Okay, so here at 20, you can see that it should be here almost near to 15. At 25, you can't see any increase in the amount of product. So at 30, there is no change and the reaction has finished. Whatever the amount maximum you get here after 30 seconds. So what this graph tells you? This graph tells you, number one, amount of product and the time that is passing. Second thing that is very important, the slope. This slope of the curved line tells that how fast the reaction is going on. Okay, if it will be steeper, it means you should know that it is not as quicker as if it will be like this, just moving upward. It means the amount of reactant within seconds. Look, almost here at 10 is it's touching here. Okay, within 10 seconds the amount reaches at 20. So it's mean the speed of reaction we can also easily find out with the help of this graph. So any question till here? Yes, please. Okay, that's great. Thank you, Walid, Umar, Nabil, Ahmad. Thank you, my dear. Okay. After understanding, okay, Ziad, thank you all of you. Thank you, Mustafa. Now, let's move to the next slide here after understanding the graph. Now, factors that affect the rate of reaction. Same in your textbook. You can see here in your textbook, after understanding this graph, the second thing we can see here on your textbook page number, the steeper the slope, the faster the reaction. Look how it's moving up. As it's going to curve, it means it's slower down. So the things, the factors that affect on the rate of reaction, we going to move from your textbook page number 206. Okay, this is all the things we're gonna discuss one by one. The first thing that is about the concentration. Second one is the temperature, then the surface area, after that pressure, and then catalyst and the sunlight. So we already learned about them in detail. Now let's see in a brief or a short way. So first, the effects of concentration. You can see here, there in the box A that I mentioned, this one A, and this is the B. if amount is more, like here in the B box, high concentration. So here the chance of collision is more. Understand? So it's mean here you can get the reaction easily, more quick way, faster way. And if the amount or the low concentration, the chance of collision is less, minimum, and they will not going to give you a product more quickly. So by increasing the concentration, number of particle increase, due to more particle, collision increase and lead to increase in the rate of reaction. Very simple. Now after that, because we almost have 5 minutes to end this reaction. Second is here, effect of temperature. You know very well what temperature affect on the rate of reaction. As temperature increased, you know very well what happened. The Ke, mean to say kinetic energy of the particle increase. When the kinetic energy increase, it's mean the collision increase, and we can get more effective collisions that also lead towards the increase in the rate of reaction. So by increasing temperature, kinetic energy of the particle increase. Due to more kinetic energy, collision increases, that leads to increase in the rate of reaction. Everyone understand? Okay. After this, the third thing that affect on the rate of reaction, that is the surface area. You know very well, just as to observe or see the thing, this box maybe it's looking bigger, but unfortunately it has low surface area. And you know why? Because I already explained you this thing. As you make it pieces and pieces and making it more smaller and smaller, as even you can find a fine powder, okay, how much you can make it more smaller, it's mean you are going to increase its surface area. So when more surface area of a particles, they are more exposed, they are more open to react with other particles. So rate of reaction increase by increasing the surface area. You know very well how we can increase the surface area, as we can divide or crush a particle and you can just make it as in a powdered form. It will more good for you for a reaction. Like here in your textbook, you can see the example of the potato here, as he just this about the collision theory that I already explained to you. Like here, this is the nail. As you cut this in the small pieces, look, all and maximum particles are exposed for the reaction. Okay, and here I also, this one is the potato. How you can make it more pieces, it will able to react more. Okay, so increase in the surface area, what can it do? It's also more and these greater chances to reaction. So surface area increase by decreasing the particle size. So till here, any question, anyone, please, most welcome. Otherwise type no in the chat. Very well done. Okay, now let's see almost the second last topic, or the second last effect that may be not mentioned in your textbook, but I just explained with the help of this example. Like the marble chips made a calcium carbonate, they react with hydrochloric acid to produce carbon dioxide. That is in front of you. The effect of increased surface area on the rate of reaction can be measured by comparing how quick the mass of the reactant decrease using marble chips or the different size. So conclusion here, it's mentioned reaction of smaller pieces of the marble with HCl is fast than in big pieces. Okay, so reason small pieces of marble have more surface area and more particle easily affect. Now the fourth factor, that is about the pressure. As you know that when we increase pressure, what happened? The particles are come more closer and closer to each other. So as you can see here, I just going to draw a graph or a box here that will make the concept easy for you, like this here. Okay, in this box you have you can say that how many, 1 2 3 4 5 6 7, okay, like this. But what you do when you put pressure on it, or you can say that you just pull them back or push them back in a small surface or small area or small volume, what happened? They again come closer and closer to each other. Or in other way, you can say that you just reduce their volume, their space. Then what happened? By increasing pressure, my dear student, particles become closer to each other. When particles get closer, collision increases. That leads to increase in the rate of reaction. Very simple, super easy, I know. Yes, well done, Mr. Walid. You reply very well. It's great. Now, after this, what are catalysts? Okay, about the catalysts are the substances that change the rate of reaction without being used up in the reaction. They are chemicals, substances, they didn't use themselves. And in the end of the reaction, you can get back catalyst as same as you added. So that a special type of species, you can say that the chemicals, they affect in a rate of reaction. In this way, they can increase basically, okay, the rate of reaction. Catalysts never produce more products, but don't think that they can prepare or make more amount of products. It's impossible. They're not going to increase the amount of product. They just produce the same amount, but the most important thing here, more quickly, because catalyst is not any reactant. It's only to increase or speed up a rate of reaction or a reaction. Okay, specific catalysts are used for specific reaction. You can't use all types of chemicals or all types of catalysts in every type of reaction. No, because they are specific in their nature. So it's mean one catalyst is not used for all reaction. Very easy. Here in human beings, you know very well, in bio you learned about the enzymes are biocatalysts like lipase, protease, amylase. They help you in digestions, like this. So example of catalysts are also written here. Fe metal is used to catalyze in Haber process. Okay, so the process to make ammonia gas from nitrogen and hydrogen. And nickel or platinum metal is used as catalyst to convert vegetable oil into margarine, yani ghee. Okay, and vanadium pentoxide is used in contact process to make sulfur trioxide gas. This is also a contact process, is used to make sulfuric acid. Okay, so here again, what actually catalysts do? That is the most important part of the lesson. So you should focus on this one. Okay, it's really help you. Actually, the role of a catalyst is what? Look here, without a catalyst, what happened? The reaction need to come here. Okay, then the product is formed. Okay, this is called the activation energy. Without a catalyst, the reactants first need this amount of energy. That is energy they needed. So you can see that from here to here, how much energy they needed. Okay, this amount. But when you add a catalyst with catalyst, the amount of energy is reduced till here. So this is here the activation energy. So in simple words, you can say that a catalyst reduce the activation energy or lowering, decreasing the activation energy. Understand? Rate of reaction is increased. How? When they lower or decreasing the activation energy of a particular reaction. So catalysts provide alternate path for the reactants to be converted into products. Easy, my dear? Only this is the role of the catalyst. Okay? Any question till here? Quickly, I have only last minute and then the meeting should be ended up. Okay, so I just move quickly on the next slide. This was about the light, as we already learned. Rate of reaction increase by increasing the intensity of light on the reactant, the rate of photosynthesis, as you know very well. This about the example of the photosynthesis, and the rate of photosynthesis is faster at daytime and stop at night. So it's mean light is also affects on the rate of reaction. Here you have a couple of assessment pages, like the first one is here, that is define the rate of reaction.